Hi everyone, welcome to the webinar organized by Transility. My name is Sheetal and I'll be the moderator for this event. Today's session is all about microservices, magic and myths. I would like to introduce speakers of today's session. Our first speaker is a cloud expert with extensive experience in designing and architecting world-class solutions for enterprises. He is passionate about serverless computing and containers. Please help me welcome Aditya Parasrampuria. Our next speaker is a solution architect in Impetus. He is primarily working in microservices and cloud-based solutions and related technologies. He is having expertise and experience over 16 years in designing and development of enterprise software applications. Please help me to welcome Ashish Dutt Sharma. Our third speaker is a technical thought leader and author of a book. He has written many articles and papers on latest technologies framework with recognized publishers. He is intimately knowledgeable in design and development for enterprise solutions, product as well as cloud innovations that can be used to maximize the benefit of modern technology. Please help me welcome Raghvendra Singh Dikhet. One request, I would like to encourage all the attendees to ask any questions related to session in a Q&A window, which is open now. We would love to hear from you. So without much ado, I'll hand over further to Raghvendra. Over to you, Raghvendra.
Thanks, Ital. Welcome you all. I hope so you all are doing good. So today we are going to talk about microservices, magic and myth. So we are not going to provide any kind of a training or coaching, right, or technical stuff and details regarding the microservices. It's a more of a sharing insights and experiences, right? So being an architect, we have been working on different clients, different assignments where we extensively used microservices. And that experience we are going to share here today. So this entire session, next 30 minutes, has been divided into three portions. So first, I will take care, which is talking more about the insights, where I will talk about some business need, success stories, what the business value have been delivered with the microservices. Then we will talk about magic, which Ashish is going to take here. He will talk about best practices, advantages we can expect from the microservices, which is sort of a magic. Then Aditya is going to walk you through some misconception and open questions. That's a part of a third part as a maths. Later, we'll be taking care all the Q&A. So let's before starting, I would like to introduce our company. So what all we are doing it, right? So we are basically software solutions and services company. We are almost 30 years old company. We are primarily headquartered in Los Gatos, California, and offshore development centers across India. So we have our presence in NCR, National Capital Regions. We have a couple of offices there. We have presence in Central India, a couple of offices here in Central India as well. Then we have our office in Bangalore, which is kind of a Silicon Valley in India. Then we have around 2,500 plus engineers. We are working in a primarily many technologies, cloud, big data, mobility, UI, UX, right? That all we take care. We have been working primarily with Fortune 500, 100 companies and large enterprises. In terms of services, we take care of feasibility analysis, consultation, architecture and design, user experience design, development, testing, deployment, and post-deployment application infrastructure monitoring as well. So in short, I can say that we are providing end-to-end services for applications development. Okay, let's go through microservices insights. So I'm going to share this webinar and talk about microservices with a really good quote. So let's talk about the journey of 1,000 miles begins with one step. So that same is applicable with microservices as well, right? In a microservices world also, the main concept is dividing thing into a small services, right? Which is called as a microservices, right? So that really going to simplify your long and big solutions actually, right? So that the way microservices are going to solve your big objectives and missions into a smaller steps. There is a golden rule for microservices. So change a microservice and deploy it without changing anything else, right? So that's a golden rule for microservices perspective. And later in the slides, later in the contents, later in our sharing our experiences, you will realize what this golden rule means is and how it is going to be applicable for all the microservices perspective and what all outcome we can expect following this golden rule. Let's go through one basic questions. First of all, why we need it? What is the business need? Right? Definitely, there are a lot of technologies comes and go. Right? Each one has their own pros and cons. But why microservices? What is the business need? So there are many important things. Right? So the important thing is time to market. Right? So the way industry is moving up, the way the competition in the markets, the time to market is a really key. Right? So anything, any business idea, something you want to roll out, the time to market is going to be key. Where microservices gives a really good advantage. They really helps to expedite the development and keep the things into reality. It also helps for improved productivity. So if you have suppose parallel team working on different things, right, kind of dealing with the agility as well, so it's like with the time to market and competition, a lot of agility also comes in. At times you would like to implement and mature your applications with user behavior. You would like to understand the adoption of your application, adoption of your business logic, and accordingly implement the things, right? So and even competitions, things like pandemic, they also change the user behavior. They also change the market condition. So your technology is empowered enough for the to take care of the agility, where the microservices come into a picture for that perspective, right? Your microservices empowers your entire system to be provide the agility and quickly changes as per the business need. Last but not the least, so fault tolerance and resilience. So system has not to be like has to be resilience enough. It should not be like okay, the one component is down, so entire system is down. So that's the way system has to be, right? They should always be providing 24/7 availability, right? And they should be running in all the situations, right? If I talk about just a month before, there was a cloud outage, right, which cost many things about $1 million to many companies, right? But that kind of a thing should not happen, right? So how that is also kind of a business need. They would like to run always. So we talked about business need, right? But if we use microservices, right, what all we can expect out of this microservices word, microservices technology perspective, right? So I'm not going to share a big theory here, but a couple of use cases, couple of more important things which we can directly expect, and we have been doing with a also seeing similar line with a couple of clients as well, right? Which they can expect some kind of a thing. So in a microservices perspective, you can definitely expect some reduction in the data flow, right? So if suppose your application set having very data intensive, lot of data flows goes here and there and between the different services, different portals, right? So microservices can help to optimize that, and there are use cases where it has been reduced up to 50%, which is a really good saving. And not just this data saving is going to give an advantage in terms of computation saving, right? Power saving, a lot of things implicitly come into it. Similarly, in line, even the cost saving, right? So if your computation is going to share or your data flow is optimized, right? The data like the overall cost can be saved up to 20 to 50%. So that was also we have seen working with the different clients. And if suppose you have a really large system, right, where you need a hundreds of a microservices, so that can also be done. We have also been doing such kind of a work where we implemented hundreds plus and hundreds of microservices, right, is still very much manageable and they're able to take care high availability, right, independently scalable as well. So that kind of a system also comes up, right? So microservices comes with many business value. It can give us an outcome. Right, and in subsequent slide, we are going to talk about the more on same similar line. Let's talk about quickly the future, how we see the trends, right? So we have talked about business need, we talked about what the value we can expect from microservices, right? So, but what the trend is saying that, so from the trend perspective, so by 2025, we see that global cloud microservices business is going to be around $3 billion. That's really huge, right? And even the developers adoptions, enterprises adoptions is growing very rapidly. So even by 2025, we see that developer adoption by 86% and enterprise adoption is going to be 63%. And with very confidently, I can say that very soon microservices is going to be a default architecture pattern for any kind of an application solutions. So that the way microservices is going popular and getting adoptions and enterprises developers. With this much insights, I would like to invite further Ashish to share the magic aspect to it, where he's going to talk about the best practices and various advantages. Ashish, over to you.
Thank you, Rakvind, and hello everyone. So, in this section, we will see how microservices doing the magic, right? And what are the do's and best practices involves in the in the background, which is doing this magic, right? Okay. So some of the key considerations, or I would say the best practices, right? So the very first point here is communication between microservices. Let me tell you that when we are talking about microservices, right? So just think about a system which is huge, right? And as Raghavan mentioned in the earlier slide, that there are systems which are having more than 800 plus microservices. Now, if we'll compare it with the monolithic applications, like the traditional way of applications, right, where we were having a server and a client, and once a request come to server, right, all the communication between different components happening uh, using a simple native calls. But in microservices, we have different services in an umbrella, and to perform a simple business use case, these microservice components used to interact with each other. So communication is a very important aspect, and if it is not chose you know uh, it is not getting chose consciously, then probably it can create a lot of issues related to performance, and can impact your overall design, and you cannot see that magic. So principally, we can say that communication in microservices can be divided into two parts. The very first thing is synchronous communication, like your HTTP communication, and the other one is asynchronous communication, like through message brokers. You are sending a message for communication to other microservices. One is blocking, one is very rapid, and both are having their own use cases. So it's very important to choose and decide your communication strategy very wisely to see this magic. The next point here is database strategy. So in microservices, there is no thumb rule, right? You can decide the strategy of your application. You can decide the strategy of your overall, infrastructure as per your decision or as per your choice. But definitely there are some do's, and you have to be very sure about it. So the recommended strategy here is you should have one database or one data source per microservice. So it is not restricting you to use a shared database or data source approach. It can be possible, but in that way, it's you will not able to utilize all the powers of microservices. So let's consider an example, right? You have 5 different microservices, and one microservice is uh, having require a transactional capability. So when you are requiring a transactional capability, you must be requiring a relational database, right? On the other side, there is an auditing database, which is just putting all the things right in document format in a NoSQL database, right? So there probably your possible or preferable choice will be a NoSQL or a Hadoop system, right? On the other side, you might require a different document database, right? So there you can choose that. So in that way, your different microservices can choose the data sources as per their need, and this strategy is recommended in this architecture. If you want to use the shared database approach, think twice. If it is fitting in your use case, then probably you can go with that. Versioning on microservices. So as we know that
Ashish, you are not audible. Is it only to me or to everyone?
versioning of microservices. Hello, am I audible good?
Yes, yes, now you are audible.
Okay. Sorry for that. So I was there on the versioning on microservices. So as we all know that we are living in an age where we are having very rapid business changes, and if you are having an existing application or you are creating a new application, probably you require a lot of changes and modifications in your services very rapidly. So what when a new version of a microservice is required? How you will do or manage the microservice versioning? So on that part, just think about that there is a service and you are having contract with other services. Now, the very first thing is that don't break the older contract. Try, as much as possible, we have to try that the older contract should not get break. But if it's not possible, then create another version of microservice or another version of your service and deploy it. Now, how you will do this deployment, because where to keep this service? So there are two different approaches. The very first approach is add the service into the existing microservice instance and deploy it. And another approach is create another instance of that microservice with a different version and get it roll out. In that way, possibly your infrastructure cost will be a bit higher, but that is also a way. So in versioning, we have to ensure that there will be separate versions. Deployment part should be based on the cost and cost factor that how you would like to go further. The fourth part is here is microservices deployment and containerization. Now, as we discussed earlier as well, right, when there will be a huge system, it's very difficult to manage that system. There are various other challenges, right? And one of such challenges is deployment. Let's suppose if you are having more than 500 microservices in your application, then individual services are having individual different set of requirements, different set of libraries and infrastructure required for their deployment, right? Managing such kind of stuff can be a big challenge, right? Their containerization can help us a lot, where we can bundle our deployable with the required dependencies, and we'll package it in one image, and we can scale it up and down as per our needs, right? We just require to spin up a container right on our infrastructure, and everything will be automated. The fifth part is monitoring and governance, right? So monitoring, we know that how to monitor this huge system, and governance means how we are controlling this system, right? By applying different policies, different compliance rules and practices, right? How we are applying those things there in the system. So there are various different tools available in the market, right, which we can utilize for monitoring and governance. So, but that is something which is very important and a bit challenging part there in microservice world. So choosing the monitoring and governance applications is really required to see that magic what we are talking about. Okay, so now it's time for magic. So the very first thing is loosely coupled system. So every microservice is self-contained, self-deployable, separate unit in your application. So in that way, let's suppose if you need to extend a new feature into your application, so you are free to choose the technology, you are free to choose a new microservice for that, and you can, your existing system will not get impacted by that. This is what the benefit or the magic of this microservice. Every component is loosely coupled and used to work on the contract what you have decided earlier. You can extend or you can scale your application to the nth level. So that is the another very good thing. Let's suppose just talk about the monolithic application where you are having a good load on your system. So you probably need to scale the overall application, right, in a way to address that or to support that load. But here in microservices, let's suppose one of your microservice is having extra load. So you just need to scale up that particular microservice. You don't need to scale up the components or microservices which are not having the extra load, right? And as per your convenience or as per load, you can scale it up as well as you can scale it down. So in that way, you can address the different kind of loads as well as you can optimize your cost. Uh, Technology neutral. So as I said earlier, right, whenever you are planning for or designing for a microservice, you are free to choose the technology as per your convenience, as per the requirement, which is fitting best in your use case, and the team, your team availability, right? Let's say if one of the microservice, what you are planning, uh, requiring logging capability, right? And you require to have a NoSQL database for that. You are free to use that, right? You don't need to bother about that. What the other service is using is it using uh, the SQL database or any other data source, right? So that is completely technology neutral. Enhanced security. So security is a big concern for every application, right? So here in microservice, you're having several components which can identify the security risk and can manage the security aspect at the very top level. And whatever requests are going or floating through your microservices, right, within your cluster. So they are very much secure, and in that way, you can address all the security and compliance risk at the very top level. So these are some of the magics what we have talked about. Uh, in the next slide, Aditya will tell something more about microservices. So it's hand over to you, Aditya.
Thanks, Ashish. That was quite informative, I guess, for the audience. So in this section of our presentation, we'll be talking about the myths, the common questions that people have in their mind when they actually plan to transition to microservices from their probably a SOA-based architecture or a monolithic architecture. Some of the open questions, and this is something we come across when we deal with clients belonging to different application verticals. So they have this thing, a set of questions that come to their mind more often than others. So the first one being, what's the difference between services and microservices, right? So I would say that in this context, it is more of a factor of abstraction, right? So if you see, like I'll take an example of an e-commerce application, right? If you think that in case you want to place an order, so you would probably design an order service, right? In case you would want to have the shipping capabilities, the fulfillment capabilities, inventory checking, all of them rolled into one service, so that will be a more high level abstraction. However, in a microservices world, you would probably want to split it up specifically based on a purpose. So microservices are more purpose driven and solve a particular functionality area of the application, right? So therefore, in this case, if you are deciding to have in a services world, you would have an order service. Here in a microservices world, you would probably break it up into multiple microservices, one catering each for order, fulfillment, shipping, inventory, and stuff, right? So that's the high level idea about services and microservices. When it comes to SOA versus microservices, so there are a lot of factors I would say that are common between both these architectures, because service-oriented architecture, or SOA, was initially envisaged as having a collection of loosely coupled components that can piece together to solve a particular set of problem, right? However, there are a few fundamental differences between SOA architecture and the microservices architecture. So some of them I would like to highlight here. The one being, SOA, or service-oriented architecture, is more of an enterprise-wide approach to software development, right? And that is there, in this, this comprises of, as I said, a lot of reusable software components and services, right? When you design a service-oriented architecture. In this case, the data interchange or the data exchange format plays a very crucial role, because SOA is highly opinionated in terms of how you want to transmit data, which in this case is more reliance on XML. However, microservices don't restrict you in such fashion, and therefore you would find that microservices are more geared towards protocols that involve JSON interchange, which is tending to be lighter. Therefore, the information exchange happens much more smoothly and with a lesser payload, right? Now, in this case, there is also SOA is also comprised of different kind of service types. Now, there could be functional services, it could be enterprise services, it could be infrastructure related services, or it could be barely application services, right? And these services are, I would say, an amalgamation or a combination of multiple components themselves, right? Which is they could have a contract which basically defines how the client will interact with the server and ask for a particular response. There could be an interface as to how this service will be contacted, either through an API or through an SDK, whatever, and how the implementation is basically done, right? However, when it comes to the microservices architecture, right? So like I said, that there is a lot of overlap in terms of microservice architecture also providing a set of loosely coupled components that you can piece together to solve your application needs. However, the fundamental difference here is that our microservices tend to be more focused and geared towards the application side of the problem, rather than having a holistic view of enterprises. Like I said, because in SOA, you are having dependency on functional services, enterprise, application, and infrastructure. Microservices are more application driven, right? So therefore, that's one of the major differences, I would say, between the two. And obviously, the interoperability and granularity is way more higher in microservices as against a SOA architecture. The other question that we come across, and this is because containerization is a huge hit among the enterprises these days. So they keep asking what are the advantages of containerization with microservices. So it's like I would say a kind of a match made in heaven. Why? Because microservices help you decompose your application, the entire application, into purpose-built pieces of components, and containers help you package those pieces of application in a manner that can be redeployed at scale. Okay, so you don't have to worry about the dependencies, the interrelationship between different kind of services, because that part is taken care of microservices. All you have is an independent deployable unit of software that can be shipped and can be deployed on multiple VMs or various runtime environments as well. So therefore, it's a huge advantage when you combine microservices with containerization, right? So now, and the other question is how small a service is called a microservice. So there is no fixed answer, I would say, because that totally depends on your use case. In some cases, you would say that the entire implementation of a functionality would count as a microservice. In some cases, you would want to break it down into further pieces. And the next question, which obviously and Ashish has talked about in his address already, is how do we want to actually have separate databases for each microservice? So ideally, it is recommended that in order to have a full, the full scale advantage of microservice architecture, you should typically go in for a separate database, because that will allow you to have a more fault tolerant and resilient system. So that if that any piece of that microservice goes down, including the data store, you would still have the other pieces functioning. However, if you go in with a single database cluster, so then chances are that if that goes down, it will take with it a lot of other microservices, right? However, there could be certain cases wherein you would want to have a more tightly a coupled integration with different microservices, in which a common data store might also make sense, right? It's a recommendation to have different databases, but then that can also depend on application use case. Is service discovery compulsory for microservices system? We wouldn't say it is compulsory, but it's a big plus to have a service discovery mechanism, because we talked about the use cases wherein we have seen enterprise customers scaling to large number of microservices to the tune of hundreds of microservices, right? In this case, service discovery becomes very much important, because it helps the client reach out to the intended targets. It also helps kind of route the request to the appropriate microservices, because it simply becomes very difficult to orchestrate all your microservices, and that's where service discovery plays a huge role. It is much easier to plug and play your microservices with this kind of approach using service discovery. Some of the key myths that people carry in their mind when they set out to go in with microservice architecture. So first one, because like containerization, serverless is also hugely popular among enterprises and companies of all sizes, right? It's not the small and mid-sized firms that are embracing serverless, it's the large enterprises as well. So they also tend to ask themselves that when we are actually developing serverless services using some of the existing frameworks, right? So does a serverless service count as a microservice itself? The answer is no, right? You could still have multiple serverless services being composed together to create a microservice, right? And the other way could be true as well. So like you could have a microservice, one single service catering to multiple microservices. So that could also be a composability pattern, right? The other one is microservices are easy to maintain. So that's not true at all. Although it does take a lot of burden out of the building and deployment and maintenance of each of these pieces, but to bring them together cohesively in a manner that the application can consume them in a seamless fashion. That's the key to having a successful microservices strategy, and they are definitely not easy to maintain when they start scaling up. Obviously, if you have something like an 8 to 10 microservice, things might be in your control, but if you don't have accurate and appropriate checks and strategies in place, it could simply go out of your control very easily, right? REST APIs are microservices, not true at all, because these days, not only REST, but we are having, a lot of interest among the enterprises for protocols such as GraphQL, which is kind of a wrapper on the existing HTTP layer, but provides a lot of developer flexibility additionally, right? So you could still have a microservice that is catered to using a single GraphQL endpoint. So that's the distinction here. Microservices have a common database. We already talked about that, right? So it's not the case, right? And it should not be the case always. You have to carefully deliberate your requirements and then arrive at a database strategy. Okay. Event-based architecture can be implemented only with microservices. Again, not true at all, because with the advent of a lot of cloud computing services, wherein they have actually simplified the event-based architecture. It's not only limited to typical queue-based mechanism. It's simply like you have got services like SNS in AWS that can provide you asynchronous handoff from one operation to another, right? So in that case, event-based architecture could be like not only microservices, it could be catered to using any architecture. It's just the manner of how you want to implement or handle a particular kind of event, right? So it's not tightly coupled with microservices. Service discovery not required for serverless microservices. Like I said, it's always good to start with a service discovery mechanism, although initially you would not have the pain of setting it up, but then later on, if you don't choose to have a service discovery mechanism, later on you probably would repent as your system scales, right? Containerization is a must for microservices. Again, so that's not a right proposition, because like we said, microservices can be developed using serverless architecture as well, right? You could have simple collection of VMs handled by a load balancer. That could still qualify as a microservice, like, right? So like if I take an example in AWS, you could still write an application, a Spring Boot application in Elastic Beanstalk, that would still qualify as a microservice. You need not have containers for that. So with that, I'd like to hand over the baton again to Raghvendra, who would like to summarize what we talked about in this session. Over to you, Raghvendra.
Yeah, thanks Aditya, thanks Ashish, right? And first of all, I would like to request to all the audience to allow us few more minutes. We have been sharing our experience. In starting, I said that like it's a challenging to time bound sharing an experience, right? So I hope so you can allow us few more minutes. So I'm not going to take much time now. Let's quickly summarize what all we discussed. So we talked about success stories, business values we can expect from the microservices. We also talked about what are the business need for a microservices perspective, right? Later on, Ashish covered about the magic aspects. What are the best practices we should be following up, right? Advantages we can expect it, right? And then Aditya have given more insights talking about various misconception, open questions, which very commonly we have addressed, seen in many people, as in when they think about microservices, many things comes into your mind, which we try to capture and share our experience on that thing, right? So microservices going very rapidly, right? Growing very rapidly, and we are very much confident enough it is going to be a default architecture very soon, right? Important thing which I would like to highlight, right? Microservices comes with a lot of advantages, a lot of magic aspect, but same time it has to be taken care very properly. It has to be designed very properly, implemented very properly, right? Because microservices in short is a more of a guidelines, right? Implementation approach, but that needs to be followed very well without removing your misconception, resolving your open queries, right? Identifying the best practices that we need to follow, right? Otherwise, it can easily end up into a very complex system which will be difficult to manage. And rather than getting some advantage, it can even reduce your user base or so. So it has to be taken care very carefully. And let's hope so. As per the trend, we can expect more things coming from microservices in terms of business values or so. Now, I don't want to take much time. Let's quickly jump into Q&A. Sheetal, can we quickly look into the questions that we have from audience?
Sure, thanks. Thanks everyone for a wonderful session. We have got some questions. I'll read one by one for you. First question we have got as how can one implement fine-grained RBAC in microservice architecture?
Okay, so if I understand it correctly, right, it's about the rollback strategy in microservice. So as I said earlier, right, microservices can be built up. One microservice can have one data source, and when we are talking about rollback, so I'm assuming that the data source is relational data source. If the transaction or belongs to or is not getting spanned from that microservice. It can be easily rolled back by the traditional strategies. So there is no issues with that. But what with if that transaction is getting spanned to different microservices, and all those microservices are having their own data sources, then how to deal with that, right? So I'm not going into much technical details, but there are several proven patterns in microservice world to address this problem. Uh, Saga pattern is one of them, where you can deal with a fine grain rollback strategy. You can deal with transactions. So yeah, Saga is one of them, and there are different variations of Saga also available, right? Which you can implement to deal with transaction and rollbacks. Yeah.
Thank you, Ashish. So next question we have received as how to break my monolithic application into microservices.
Yeah, so I can take this. Because we already talked about this as part of some of the open questions that people tend to have. So having a monolithic application requires you, and when you want to migrate it to microservices, the first thing you would want to require is to have a clear-cut understanding of your functional areas, right? What kind of functionality is that application catering to? Then once you have identified those, you would then identify like the endpoints and the pieces of the application code which cater to that particular piece of functionality. And then the next step would be to then start having an intermediate migration process in place in that in terms of breaking down the code in such a manner that it can be then taken off into a separate entity without affecting the core business logic. And then as a final step, you would then want to have this standalone, microservices catering to a particular business use case or functionality. In this cases, you would also have scenarios wherein you would have some utilitarian pieces of code. So it's not recommended to have that piece of code getting replicated on all the microservices. You should have a common packaging unit in place. Like it could be, for example, in NPM, it could be a common utilitarian package that you could import in multiple microservices. Try to offload that common code there so as to not rewrite that at every places. And then obviously each of the microservices would then have their respective functional code only. So yeah, that's a way to go about monolithic to microservices.
Thank you, Aditya, for addressing the question. So we have got few more questions, but as we are running out of time, so we'll answer all the other questions over email. Now I would like to thank you. Thank you for joining the session. We trust you enjoyed the experience and session was knowledgeable and fruitful for you. A recorded version of this webinar will be available at YouTube channel. For more information, you can write us to connect@transility.com. Looking forward to meeting you again next time in our next webinar. Thanks so much.